In this video from the math workshop, we will explore the math routine of tell me all you can. This math routine can be used with mathematicians of all ages and levels, both big and little. Here are some ideas on how to facilitate this math routine. This math routine is very open-ended. There is an entry point for every student. You could use it as a warm-up when students enter math class, or you could use it at the end of math class as an exit ticket. It's really no right or wrong time. The point is not for students to provide the exact answer, but everything else they can think of about the problem or the image. Our job as educators is to ask, listen, and learn about our students' thinking. We recommend using talk moves to facilitate the discussion. Give students the gift of silence, that think time before taking comments. Share and post examples with students, and I'm going to share some with you in just a moment. And a fun extension could be ask student pairs or trios to create a list of 4 tell me all you can statements, with one being a lie or one being false, for another group or pair of students to figure out. Here are the talk moves: revoicing, repeating, reasoning, adding on, wait time, turn and talk with your partner. These are the 3 categories for this math routine that are included in our Google slide deck, which you can purchase from our website for students in grades kindergarten through 6th grade. We have models, we have numbers, we have equations. We have over 300 examples. Let's look at some of them. Let's go into models first. So here's an example of a model, but there are also examples of possible student responses. We recommend that you share these student responses initially with students just so they get the idea of what is expected of them in this math routine. So some possible responses would be to this image of 8 dots. There's a full 5 row and there's 3 extra. There are 2 missing from the 10 frame. This is less than 10. I know that because a full 10 frame would have every square covered with a circle. There is more than 1. There are 2 sets of 3 and 2 more. Do you see those 2 sets of 3? It looks like the 6 pips on a dice and then the 2 extra. 1 more would equal 9. 1 less would equal 7. Notice in none of those statements says there are 8 dots. Because again, tell me all you can is really a math routine about beyond what the answer is. So students kind of have to get used to that idea. It's a different idea, but it tells us so much about their thinking. Let's look at another example again. This is a slide showing you what students might say, and this is for a 100 chart. And notice, or 100 grid, notice there's a grayed out portion, okay? So students might say, and remember there's a really low bar entry point, everyone can say something about this image, all right, and tell me all you can. So here are some possible responses. There is a 100 grid with some shaded parts. There is a full 10 row shaded. There are 9 10 rows unshaded. There is more than 1 and less than 100 shaded. This is less than 50 because I can tell that less than half of the 100 are shaded. This is more than 5. So again, all of those are correct, but we can tell a lot about where students are in their thinking based on their statement. And we're not publicly evaluating their statements. It's all data that we're collecting, but we're facilitating this discussion and having students listen to each other. A recommendation would be for those statements that are really amazing, hover on those ones. Those are the ones where you'll want to say, oh, who heard what Jose just said and can repeat it? And if none of your students were listening at that time, say, Jose, that was so amazing. Can you repeat that? And I'm going to ask again, who heard it and can repeat it? So that repeating talk move is an invitation for students to listen to each other. And we only want to use it when it was really something you want to resonate around the room, that clear thinking that you think maybe when the child said it the first time, not everyone really heard it or really got it or really understood. So it's a time to pause and hover. Here's an example with a fraction model of possible student responses. There are 4 columns. Some are shaded and some are not. There is 1 out of 4 shaded parts, or 1/4. Okay, that was an example where the answer came up. Sometimes students are going to do that. We just accept it, but we say, tell me more. This is less than half. And it's great if kids can tell you how they know that. This is more than 0/4. This is less than 4/4 because that would mean all of it would be shaded. And if you want to push students to tell you more, maybe they just say something like, this is less than half. You can say, tell me more. Or a talk move you can use is, who can add on to that thought? So now we're looking at a slide example that is without the possible student examples. So remember, those possible student examples were just to get your kids warmed up and thinking about what this routine is like. But normally you're just going to show a slide like this. We're in the models section, and it's just tell me all you can about this. And remember, you want to give your students think time, because not all of us are fast thinkers. I'm not. So I respect a little bit of quiet time to think before I'm asked to share. This would be a kindergarten example. But sometimes, of course, there are students in other grades that would benefit from kindergarten math standard examples. And so that's why we've included in our Google slide deck K through 6. So you can differentiate. You could do this with small groups in your room. So the deck is arranged within those 3 categories to get progressively more challenging. Here's an example using base 10 blocks. Here's another example with the 100 grid. Here's an example with fractions. I love this one. Students are asked to think about what the shaded region represents and tell me all you can about. Like right away, I can see, wow, this is definitely less than a half. Even though those 2 shaded regions or portions are not together, it's okay. I can be flexible in my thinking. My eyes can see it's definitely not going to represent a half. It's much smaller than a half. It's a little bit more than 0. A little bit. It's a small amount. Here's an example. We're still in our models with a number line. Students are asked to focus on the location of the star. Again, tell me all you can about. This is a really good example because it's probably pretty hard for us to come up with a precise, exact answer when it's displayed up on a board and we're not using any tools for measurement. So we can really show our number sense here. And our students noticing where that first hash mark and what the number is there, which is strategically there to provide information for us. and what the other hash mark, what that number is. Here's another number line model example. What do you think students might share? On this one, we're focused on where is that smiley face? What point or hash mark or location on the number line do you think that represents? Now, I have to be honest with you. This number line, whenever I'm teaching courses or workshops for teachers, really bothers them. Do you know why? They don't like that there isn't a place for the one. But I'll tell you a hint. We have everything we need to know in this example. Don't tell your kids this. Let your kids figure this out on their own. But from the 0 to the 1/4 mark, that's a very important line segment, giving you information on the length of a fourth on this particular number line. So you have all the information you need to figure out roughly where that smiley face is presented. So I challenge you, don't always provide on a number line the 1. Don't always go from 0 to 1 for your students. They can be challenged. They can be flexible in their thinking. Take that 1 away, but give them enough information with that iteration of whatever the amount you want to be, that they could use that length to figure out approximately wherever the star is or the happy face or whatever little image you're using. Here's a 6th grade example in the models section again. And this one's with coordinates on a grid. And, maybe the 6th graders are going to tell you exactly the location of the dot. That's okay, but then push them. Tell me more about it. And hopefully they'll be talking about those positive and negative coordinates. So let's take a peek into the numbers section. That's another category in this math routine. Here's an example for kindergarten. Again, just for kids to kind of get their heads around what to do with this math routine. So if 1 was what was provided, some kindergartners might say, especially if they have a number path in their room or some models to help them, it's more than 0, it's less than 2, I have 1 nose, I have 1 cat, we have 1 teacher, I have 1 brother, my sister is 1 year old. So we know young students are going to make it very personal, and that's great, especially with number, because we want them making sense of number. So that's, again, just an example of all the possible, and I'm sure there's many more, but possible responses students could give. Oops, went a little too fast. Here's an example with fraction. So we'd present 2/6. And again, these are possible student responses. And again, we've got a really low entry point, but we can really learn from our students. And what I mean by that is students can tell us anything that they're noticing about what we're presenting. So students might even say, it's not on the slide, student might say it's a fraction. That's acceptable. Yes, it is. There's a 2 in the numerator. There's a 6 in the denominator. This fraction is equivalent to 1/3. I might ask that student, ooh, tell me more, or who can add on to that? Because we'd love to hear that because, I know because this fraction is less than a half. Maybe a student says, I know this fraction is less than a half because a half would be 3/6. And this is 2/6, and that is 1 part less. Another student might say, I know this fraction is greater than 1/6 because this is 2 out of 6. So it's actually 1/6 more than 1/6. Another student might say, I know this fraction is less than 1 whole because I know 6/6 equals 1 whole, and this is just 2 out of the 6. Another student might say, this fraction can be decomposed into 1/6 and 1/6. Listen to all of that learning, and it comes from the students. This isn't us telling them what to say. It comes from the students, and they learn from each other. So again, using that repeating talk move strategy, you can really hover around the really interesting ones. Okay. Let's look at another example. So here's another example with decimal. Maybe the first student says, I notice it's a decimal number. Yes, it is. Oh, I have a typo on the slide I just noticed. I will fix that. It says there are 32 nines in this number. No, there's not 32 nines. So if that happened, if a student, and we know this happens, student says something that's not correct, I love to go ahead and record it and see who in the room might speak up and say, actually, Miss Brewer, I don't think that's right. Or maybe after they're all recorded, then I pause and say, I'm wondering, what do you think about all these? Let's evaluate these for a moment. And again, we're not making a big deal or making that particular child, we're not even going to say who said it. Not making them feel bad, but it's a moment of learning for all of us. So my typo is there's not 32 nines in the number. There's 2 nines in the number. It is 100th less than 1. There are 9/10ths in this number. There are 900ths in this number. You read this number as 99 hundredths. This is less than 1. And again, if a student didn't provide more with that one, I might say, well, how do you know? What's the because? Or who can add on? Let's look at all those great responses. So the whole numbers go all the way up to millions, again, because we want to support in our slide deck, we're supporting kindergarten up to 6th grade. But it's not only just whole numbers. We have fractions, decimals, negative numbers too. And in the equation portion of our slide deck for tell me all you can, let's look at some of the examples. So again, we're going to start off pretty low, kindergarten level. And here's a kindergarten, maybe grade 1 example. I mean, there might be some grade 2 students that would benefit from looking at this. So we've got 4 plus 4 on the screen. And again, this is possible student responses that we could share with students so they get their brain around. It's not just the answer. In fact, the answer is not even up there. It's other ways of thinking, pushing ourselves to tell me all you can about this equation. So here they are. It's more than 4 because one of the add-ins is 4. So it's got to be more than 4. So I'm showing that I understand that addition, that joining of our two add-ins. It's less than 10 because I know 5 plus 5 is 10. And this is 4 and 4. And I know 4 is less than 5, so it's got to be less than 10. The answer will be even because 4 and 4 are even. And I know when I add an even number and an even number, my two add-ins are all going to match up and result in an even number. Wow, that's awesome thinking. We would be so happy if we heard that from students. It's less than 10 because I have 5 fingers on each hand. So 2 hands would equal 10, but this isn't 5 and 5. This is 4 and 4. So it has to be less than 10. All right, look at that great thinking. We would be so happy to hear that from kindergartners. And some of these kinds of thoughts you are going to hear. Operations included in this deck for equations include addition, subtraction, multiplication, division with whole numbers, fractions, decimals, and negative numbers because we're taking it up to 6th grade. We hope that this math workshop video was helpful to you in understanding how powerful and fun and very open-ended, again, with that entry level, that's a pretty low entry level, but can be taken up to the ceiling for our students to help us learn about their mathematical thinking and in supporting our young mathematicians to share and learn from each other. Again, it's not coming from the teacher. We're not telling them what to think about these models or numbers or equations, it's coming from them. And if you find that your students are struggling, just back up the numbers or the equations or the models you're using, and you can revisit and slowly build over time. You will be impressed with, I would really recommend starting with models. Those visuals really seem to really open up the mathematics for students before getting to the more abstract numbers and equations. Feel free to check out more of our math routines. We are building our library of videos and materials on the math routines daily because we just think they're such a powerful part of math class. So check them out as we're releasing them on our website, themathworkshop.net, or go to our YouTube channel where we have video examples for free of, we're building that library too, all the time. But we thank you for your time today, and we hope you have a great rest of your week.